Hello and welcome, my dear students, to my channel Mathematics Made Easy. This video is specially for grade 11 elite students, those students who are moving from grade 10 to grade 11 in the next month. So I have in advance made some videos for the lessons that you will be studying. So this is lesson 1.1, Introduction to Vectors. Today's session is going to be part 1, and in today's session our learning objective would be to represent and operate with vectors geometrically. So I'm going to give you a good introduction to vectors, what are they called, how to draw them, how to solve the problem. So let's dive into the video, and welcome to term 1, first video for grade 11. So before we go to the concept of vectors, I want you to know about the concept of scalars. So a scalar quantity is a quantity that has only magnitude, like a number with units. So let us take some examples from physics, like speed, distance, and age. These are scalar quantities because they can be represented only in terms of number with units, like speed is 35 meters per second, distance is 25 meters, and age is 16 years. However, a vector is different. It has both magnitude and direction. For example, with velocity, it is 35 meters per second in the direction of north. Acceleration, it's 10 meters per second square in the direction of south, and displacement is 20 meters in the direction of east. So both are opposites, and we are looking into vectors. So we are going to write them with a capital letter like capital V and an arrow above it. The arrow tells you the direction. So the velocity, for example, here represented by V with an arrow on the top is 23 meters per second, and the direction is northeast. Now, one point that you need to be careful for vectors when you are especially drawing or writing them is that the length and direction of a vector should be drawn to a reasonable scale size and show its magnitude. So, for example, the smaller blue vector is representing 10 kilometers in this direction. Then 20 kilometers would be drawn double the size. So here 20 kilometers represent 20 kilometers in magnitude and in this direction of the arrow. So we will draw it 2 times the size of 10 kilometer. So you have to take a reasonable scale to show the size and the magnitude of the vector. So as you have understood from the previous slides that a vector has two properties, it has direction, it has magnitude, that is the length. So if P and Q are 2 points, then PQ vector is the vector drawn from P, this is the tail of the vector, to the head of the vector Q. And in coordinate space, you will be representing it by a vector, as you will learn. So if two vectors PQ and RS have same magnitude and same direction, they are called equal vectors, or they're also called as parallel vectors. So you would see here PQ is parallel to RS. In fact, both are equal vectors as their magnitude is same. Next point about opposite vectors, or vectors which have same magnitude but different direction. So A B vector from A to B is A vector, whereas from B to A is minus A vector. So these are two equal magnitudes but opposite direction. So they are also parallel. Next is triangle law for vector addition. This is a very important law that you will be using to find the resultant vector, and you'll use it also in physics. So if A to B is vector A, B to C is vector B, then from A to C, that is from the tail of the first vector to the tip or the head of the second vector, would be the resultant. So the vector of multiple vectors is known as resultant vector. So the resultant vector here is AC vector or A plus B. So just add them up. Now similarly to addition, you can do subtraction. So in subtraction, the only thing which will change is the direction. So A minus B can be written as A plus minus B. So if you have two vectors A and B, just change the direction of B. So if B is going in this direction, opposite is minus B, and then add them up to get resultant. So that's vector addition. Now what's a zero vector? A zero vector represents no moment. It does not have any magnitude. So in two-dimensional, you can write the horizontal and vertical both component as 0, 0. So these is zero vector. Then a scalar is a normal number. We've already done about scalars, which can be used to scale a vector. So the direction will be same, but the magnitude will be different. So for example, if you have a vector A and you want to draw 2 times of it, magnitude 2, then you will make the size 2, and if the scalar is negative, you will change the direction. If it is minus a by 2, means the magnitude is decreased, so it will become half of the original vector. Any vector parallel to the given vector A can be represented as lambda. Understand the concept of a unit vector. So here you see a vector which is a 3 units on the horizontal and negative 2 units because it is going down on the vertical part. So if you look at your coordinate plane x and y direction in 2-dimensional, then the displacement or the value of the vector is the displacement in the x and y direction. So you can see here a and b. If we take these two vectors, then a plus b and 2 times a, how we can find? Let's see. So a plus b would be 3 plus 0, which is 3, negative 2 plus negative 1, which is minus 3. And 2 times of this would be just 2 multiplied to each of the value. So your vectors would be like this. Now coming to a unit vector, it's very important. A unit vector is a vector of magnitude 1 because the name suggests unit vector. So let me write. So hint is unit means 1. So its magnitude is going to be 1, and I and j are the unit vectors in the x and the y axis. So along the horizontal x axis, see, you know the horizontal is x, the vertical is y. Along the horizontal axis, I is the unit vector and j is the unit vector along y. I and j both have magnitude 1. So if you take their magnitude, both have length 1. These are unit vectors. So I can be written in the magnitude in the vector notation as 1, 0. J can be written as 0, 1. So here you are using that the unit vector has x component on the top and y component on the second row. So this is how you are writing. So if a vector 4, 3 is given to you, it can be represented. Any vector can be represented in terms of I and j. So 4 and 3 can be represented as 4 times 1, 0 plus 3 times 0, 1. So 4i plus 3j. So this is very important. Any vector can be written using I and j, the unit vectors. So now you'll see a question. So let's solve this question. Here you are given 3 vectors a, b and c in the form of I and j. You have to do 2 things. Number 1, write a vector in vector form. So vector form means this form which is given here. U is equal to x and y, where x is the x component, y is the y component. So vector A, if you look, only has I, that is, it only has x component, so its answer would be 3, 0. If you write second part b plus 2c, that means b vector is as it is, c vector has 2 times, so we will multiply with 2. So it will become 2 times I minus 4 times j. Now combine I with I plus 2i is 3i, j minus 4j is minus 3j. So this is how you solve vector question. Okay, magnitude of a vector now. The magnitude of a vector can be written in this form, that is, you put the bars and the vector inside and you measure its length. So for example, A point to B point, you are having a vector AB with x direction as x component 3, y component 4. Then the formula to calculate its magnitude, that is, you write the vector AB with the arrow inside these bars, can be written as the square root of the distance. So you remember Pythagoras theorem you had done for a right triangle. So here also you see a right triangle. Horizontal component is 3, vertical component is 4. So 3 square plus 4 square, that's 25, and its square root is 5. So the formula you will use is, if a vector is x comma y with x component and y component, then the square root of their squares is the magnitude. Now, can you find the magnitude of this vector? Please check your answers towards the end of this video. Now, a unit vector we have already done is a vector with magnitude 1. So if you are given a vector like this, a equal to 3 comma 4, we can convert it into a unit vector by dividing with the magnitude. So if a is any vector, then the unit vector, and remember when you write unit vector you write this symbol. So this is a unit vector with a cap, and with an arrow is just any vector. It can have any magnitude. So a cap or unit vector is the vector divided by its magnitude. So you find the magnitude, divide it by that, and that's what you get. So let's check your understanding now. So here a vector is 12 comma minus 5. So find its magnitude, divide by that. So divide by 13 and get your unit vector. So this now a cap is your unit vector. So what's the magnitude of this? Please find now. So 1 square plus 1 square, which is square root 2. So divide by square root of 2 and you get your unit vector b. That's how you solve. Okay, let's now look into position vectors. Suppose we start at a point 3 comma 2 and we translate. Translate means we move by the vector 4 comma 0. Then what are the new coordinates? Now see, 4 is the x component, 0 is the y component. So only the x component is going to change. So 3 plus 4 would give you 7 and the y component would be same. So vectors, when they are added along the same component. So when you are adding the two vectors, we treat point 3 comma 2 in this form, so that x with x, 3 plus 4 would give you 7, 2 plus 0 would give you 2. So that's how you use position vectors. In a similar way, if you are given a vector 3 comma 2, means its x coordinate is 3, y coordinate is 2, it is used as a position vector. So a position can be thought of as a translation from the origin. So you start from 0 comma 0 and move 3 units up and 2 units right to reach this point A. That's your vector A, the position vector, and it enables you to find the position in any sort of vector calculations. So usually you denote your position vector with 0 comma A because you're starting with the reference point as origin. Okay, so OA is the position vector here. Know what is a position vector? Let's solve some questions. So you are given 2 points A and B with the following coordinates, and you need to find in terms of I and J, means unit vector, the position vector of A, the position vector of B, and the vector AB. So OA, OB, AB, three vectors you need to find. So O is coordinate 0 comma 0. So OA would be what? 3i plus 4j. So x component with I, y component with j. Similarly, what will be OB? Yes, you are correct, 11i plus 2j. And then AB is just the difference of the two vectors. So you subtract them and you get 8i minus 2j. So you can see this with this logic also. Just see, A is this point, B is this point. So how do you get B from A? Okay, or how do you get A from B? Just think in that direction. So you add 8 to 3 to get 11, and you subtract 2 to 4 to get 2. So therefore that's how you get your 8 and minus 2 vector, that is AB. Let's do one more question on position vector so that it is more clear in your mind. OA, one vector is given. Definitely this is a position vector of A because O is mentioned, which is the origin. So 5i minus 2j, 5 is the x component, minus 2 is the j component. Then you are given vector AB. You need to find the position vector of B. That means you need to find OB and then you need to find its magnitude. So OB here would be OA plus AB. And how is this coming? If you remember, AB vector is OB vector minus OA vector. You subtract them. So OB vector would be when you add it. So that's why you are adding the two vectors and you are writing them in the form x comma y, where x component is 5, y component is -2, x component is 3, y component is 4. Now it's just addition, so 5 plus 3 is 8, -2 plus 4 is 2. So this is how you draw the OB position vector. Now OB magnitude. Magnitude means you have to take the square root and write it in the third form. So this is how it will look like. 8 square plus 2 square, and if you use your calculator this will come out to be in 2 square root 17. Now why did we leave it in irrational form? Because it's written, write it in simplified third form. If this word third or this form radical was not mentioned, third is same as radical, you would have converted this to decimal also using your calculator. That would have been correct as well. That brings us to the end of today's short session on vectors, where we introduced you to the concept of a vector, how it is different from scalar. We also looked at some questions, position vector, unit vectors and all of that. So it was a good introduction. Now we move on to part 2. So coming up next on my channel would be part 2 of the session, where we'll complete the introduction to vectors lesson 1.1 for grade 11 elite. So if you found the video useful and liked the introduction, make sure you hit the like button, share with your friends who will find it useful. Don't forget to subscribe to the channel if you haven't till now, and press the bell icon so that you don't miss the upcoming next video, part 2 of this session. Until then, this is Mr. Chika signing off from today's session. See you in my next video. Bye students.